Good afternoon, everyone, and I'd like to take a minute to walk through a demonstration of a model that you could use to do some interesting things, such as determine how fast your vehicle could accelerate from one velocity to another. And this is using Cameo Systems Modeler version 2021X with the Cameo Simulation Toolkit plugin. And what you're looking at is a parametric diagram. And what this does is it recalculates every 100 milliseconds. So if you look at this, I'll go ahead and run this simulation from the get-go, and then we'll talk about how you could potentially build a model such as this. If you notice, we have a graphical user interface that complements this simulation. And what we can do is actually send a signal, and that signal will actually set a value in an activity diagram such as this. So when I click this button to perform acceleration tests, it actually sends the signal to this accept event action, which will then cause this net torque value to equal 1000. So that sets the net torque value to 1000. And then at that same time, it grabs the sim time, renames that sim time 0, and has that waiting here for this equation. And then when the vehicle actually hits a specific velocity of greater than 5 meters per second, what will happen is this token will enable this action. That action will then grab the new sim time, which will be used with this variable, and then it will take and subtract the original sim time 0, then divide that by 1000 because it's in milliseconds. That converts it to seconds, and then we can assign that value to a value property that's named acceleration time to 5, which would be 5 meters per second. And so it does that math and assigns it to that value property. And what's neat about that is that value property can have a requirement associated with it. So notice we have this requirement that says it shall accelerate from 0 to 5 meters per second in less than 4 seconds. And that's actually directly connected with this satisfy relationship to the acceleration time to 5 value property, which is the one that was referenced with that opaque action. So what we'll do is we'll go ahead and run this simulation, and you'll notice that when I click this button, this property, or that value property of net torque, which is the same as this one here, will be set to 1000, which will kick off the acceleration and the vehicle velocity. So I'll go ahead and do that. And notice the net torque would be 1000 Newton meters. That would, of course, be coming from your engine. And that's taken in. And everything is now updating. So if you notice, we have the acceleration is going down, the vehicle velocity is going up. And then we'll check that requirement here, and that we see that we did not pass that requirement because we did not do that in less than 4 seconds. It took 17.6 seconds. So now we can also perform a stopping distance test, which sets the input force to a negative amount in order to slow this vehicle down. Now really that could be done by brakes or other types of models that you would use to actually show how your vehicle would slow down. But that's what I use, basically a negative value to cause that to slow down. So in order to do that distance traveled test, what you can use is another scenario such as this. So I'll go ahead and stop this simulation now. What you see here is when I sent that signal to perform the distance traveled test, it set the value of net torque to negative 2000, which then caused it to slow down. And then if you notice, we had a value property that's named distance traveled, but that's actually a local variable. So the distance traveled property here is not actually a value property. It's just a local variable. What is a value property is the vehicle velocity, whatever that happens to be, multiplied by the delta t. And the delta t I have set with a default value of 0.1. So if you notice here, we have dt, our delta t is set to 0.1, and that's because this updates 100 or 10 times per second in this simulation. So we have every 100 milliseconds, this loop recalculates, so we can set that delta t to 0.1. And then if you notice, that calculation happens and then delivers the distance traveled to this equation with this opaque action. And what it does is it updates the distance traveled by adding that specific distance that we just traveled to the total distance traveled. And then that total distance traveled is added to what the total distance traveled was previously, which gives us our new total distance traveled. And then that loops around until our vehicle velocity hits basically stopping point. And in this case, I set it to 0.3, and that'll cause it to settle down right around 0. And at that point, I simply set the net torque back to 0. So that is an interesting simulation that you can do. I want to talk through a little bit about what is happening here. So as I mentioned, this net torque value is taken in to this equation for engine force, but then it's divided by the radius. And in this case, that would essentially be the radius of the wheels. So this model has been simplified greatly to take out things such as transmissions and that type of thing. But if you notice, that outputs here to this engine force. So then the engine force is then taken in to the effective inertial force equation, which is looking at other things such as gradient force and rolling resistance forces. And then that outputs the effective inertial force. So all of these forces that are calculated, including the aerodynamic drag force, are then summed up because all of these forces that we have acting upon this vehicle are acting in the negative direction. If you notice, we are taking and multiplying everything by -1 in these resistance forces. That way they actually act against the vehicle's direction. So that's interesting. And then the other neat thing to look at here that I've mentioned in a few other videos is how the acceleration and the vehicle velocity work. I'll go ahead and stop this, or we can slow this down. And what you'll see here is if I send this signal to perform the acceleration test, as I mentioned, it causes the net torque to equal 1000, which then feeds into the parametric and updates all of those properties. But then we calculate the new velocity by taking the current velocity, adding in the amount of the acceleration that was calculated in the parametric, multiplying that by the delta t. However, we only do this calculation every 100 milliseconds, and we can use this time constraint or the time event to wait for that value to be updated. So if you notice, that came in at 0.0571, and when this loops back around, that will be a different value, and it's because it's theoretically still accelerating. So we'll see what the next value is here, and then we'll talk a little bit about the graphical user interface. So notice the new velocity is now going to update the vehicle velocity, and that's how we cause this to accelerate. So going into a little bit of the logic behind the graphical user interface, this is a user interface modeling diagram. And if you were to want to create one of these yourself, what you could do is go to the model and search for user interface. And typically you don't see that because it's hidden. And if you click the expert mode, you'll then see your user interface modeling diagram. And then what this is one of the frames. So the frames are what you always want to start with when you create one of these graphical user interfaces. But then notice I have a group box. So there's the option for a group box for the car. One thing I should actually note here is that this is being represented as the car domain, not the actual car itself. So if we go back to the block definition diagram, what you'll notice is there's a car domain block that has a park property of the car that's typed by the car block. And the reason for doing that is because we're using embedded time series charts. So anytime you'd like to have embedded time series charts in a graphical user interface, they actually need to be one level down in your architecture from whatever is typing this high level frame. So in order to do that, because these are the value properties that I'm accessing through that time series chart are actually of the car, I had to create a level higher than that in order to actually have a part property that was typed by the car. So that's a bit of one of those weird cases in Cameo where you'd think you can just, throw a time series chart on here. But in reality, you actually had to go one level higher, create that context, and then type this group box by the part property of the car. Now, so if you notice, I have this car domain block and it has a part property typed by the car. That's what is typing this group box. And then you can drag in a time series chart. And if you notice, the time series chart is typed by the car or represents the car, and then shows that the value that we're representing in this one is the vehicle velocity and this one is the acceleration. So with that understanding, we look back at the graphical user interface and notice that this is also a group box that is typed by the part property of the car. So what this is that signal, and it's easy to add signals into your graphical user interfaces simply by dragging them in. So notice this one here, you could drag this in to a group box or some part of your frame there, and this says create a button for the from signal. And in that case, you'd be setting that perform acceleration test. What I did there was simply change the name of it. So I said perform acceleration test, something like that, right? And then you can always change the look of this with symbol properties. So when you do that, you then have the ability to send that signal, and then that was accepted in this activity diagram. So that's really neat. So then in order to run this, what you do is you can find this in the containment tree. So you're going to be looking for the frame, and notice we have this graphical user interface icon. And what we'll do is you drag that into your simulation configuration. So then notice it says GUI is the user interface. And then when you run this, that pops up, and a lot of times it pops up on a different screen. If you don't see it, you may want to only use one of your screens. Sometimes it shows up outside the boundaries of your screen. So you then have access to that simulation through your graphical user interface. And this is running with animations. So if you look back at this, that's how we see all these value properties here. But if you look back at your syn config, notice that silent is set to false. If you had that set to false, it's not going to run as quickly. So that's also something to keep in mind, is if you're going for speed, probably want to keep that in true, which will essentially just not show those value properties on the diagram as it's running, but it can be a little bit faster if you do that. So what will happen is if you run that, you still see everything on your graphical user interface, but you no longer see those value properties live in your parametric. So you can still run the simulation just the same way. I'd like to give full credit to Alex Whittier of STC for his work in creating this model. He was the brains behind all of these equations that put this into motion. So Alex, thank you very much for that. If you guys have any questions, feel free to reach out. If you'd like to subscribe, please do that, and you'll see more videos such as these. Thanks for watching.